Hey guys, my name is Aiden, and today I'm going to work on a problem for a system of differential equations. So, from Trench, number 10.4.27, we are giving y prime and then some a and y. And our initial value as our y of 0 was 6, negative 10, 7. And first we need to determine some eigenvalues. And how we can do that is we can take our determinant of a minus lambda I, and we will set that equal to 0, and so all we have to do is 2 minus lambda. We'll just track that lambda through that diagonal. 2, 6 minus lambda, 2, and then negative 2, negative 2, 2, and we will equal to 0. So, after doing that, we're going to get negative 2 minus lambda, and we're going to get some value here, so it'll be 6 minus lambda times, I forgot to do minus lambda over here, 2 minus lambda minus our 2 times negative 2, and then we will have our 2, and notice I'm doing a plus here instead of a minus, just because instead of doing like a minus 2 times 2 minus lambda, I do 2 times negative 2 minus 2 times 2 minus lambda. So you can switch them around and you don't have to worry about those negatives, but be careful with that. Why they don't teach it for some reason. So we get negative 4 minus 2 times 2 minus lambda, and our plus 6 times negative 4 plus 2 times 6 minus lambda. It's all equal to 0. So after a bit of algebra, we are going to finally come down to negative lambda cubed is 6 lambda squared minus 8 lambda is equal to 0. We pull out a negative lambda and we get lambda squared minus 6 lambda plus 8 is equal to 0. And that gives us 3 different eigenvalues. Lambda is either equal to 0, and we could do lambda minus 4, lambda minus 2, so lambda equals 2 or 4. And that gives us our 3 eigenvalues. So with those eigenvalues, we can now find out our k-values. And what we need to do for that, I'll just write these eigenvalues up here, 2, 0, and 4. So to find out our k-vectors, we could say a minus lambda I times k is equal to 0. And so for lambda equals 0, we're just going to get our original a. And it'll be 2, negative 2, 2, 6, 2, 6, 2, and negative 2, negative 2, 2. And that is all equal to 0. Now, easiest way to do this would be to actually simplify this down so we can get rid of this bottom row. It'll help just make it work out a little bit easier instead of plugging and chugging in a bunch of different k's and all that. And so for the sake of time, I'm not going to show it here, but I will show my notes at the end here if you guys want to pause the video and be able to see my work on that. Just a bunch of adding rows to each other to eliminate certain things. But with that, I ended up getting, let's see, k values, and I set my k1 equal to 2. My k2 was equal to 1/2 k1, and my k3 was equal to negative k2. So when I do k1 equal to 2, that gives me k2 equal to 1 and k3 equal to negative 1. So for that, right up here, when lambda equals 0, we have k is equal to 2, 1, negative 1. And we'll leave that on the side there and do our second eigenvalue, which is going to be lambda equal to 2. So here we go again. Just going to bring that over. We will actually have negative 4, 2, 6, 2, 4, 2, and negative 2, negative 2, 0. So all equal to 0 again. And with that, actually, so on this one, I ended up coming up with some eigenvalues of k1 equals negative k2, k1 equals k3, and I set k1 equal to 1. So for that, k1 was 1, k2 was, what did I do for that? Oh, negative 1. K3 was 1. So for lambda equal to 2, my k vector was 1, negative 1, 1. And so when you're doing these, you can actually choose any value that you want for k to make it work out, in simply just in your favor. So for instance, like I just chose k1 to equal 1 in that scenario because it was easy. I could have chose anything, it just might look messier in the end. So on the third one, when lambda is equal to 4, we would get something like negative 6, 2, 6, 2, 2, 2, and negative 2, negative 2, negative 2. That was all equal to 0. Easiest way for that one was to just add row 2 to row 3, and you get a nice 0 row right there. And then I believe I actually added row 1 to row 2 to eliminate that, so I could find an expression for k2 equal to k3, and then I had a nice expression that would have been in k1 to k2, or k3. So for those values, I got k1, I actually set equal to 2, so that k2 would equal 3, and k3 would equal 1. So over here, we have lambda equal to 4. My k vector is going to be 2, 3, 1. And with that information right there, we're actually able to write an expression for a general solution. So I would say y is equal to c1, just some constant, times k1, which is going to be 2, 1, negative 1, and e to the 0 lambda is just going to be 1. Then we get plus c2 times our second k vector, which is 1, negative 1, 1, times e to the 2t, and c3 times our third k vector, which is 2, 3, 1, e to the 4t. And so after that, we need to find out what these c values are. And what I did was I actually said y of 0 is going to be 6, negative 10, and 7. So when I plug 0 in for t, I'm just going to get 1 and 1 for that. And I could do essentially the same thing we did to find out k. I can take a matrices here. That would be 2, 1, negative 1, 1, negative 1, 1, and 2, and set those equal to 6, -10, and 7. And reason being is this would be our C1 column, C2 column, C3 column. So, we have 2C1 times C2, or plus C2, I'm sorry, and 2C3 is equal to our first condition, which is going to be 6. And with this, we can do a little bit more of matrices fun and start, adding rows together and finding out, what would be the simplest for it. So for me, when I did that, I added row 2 to row 3 and eliminated 2 of these out here, which gave me an expression for C3, which C3 would have been 4 is equal to -3. So C3 was equal, or 4C3 is equal to -3. So I got -3/4 for C3. And then plugging that into the, actually did another little bit of matrices here. So I ended up getting C2 was equal to 23/3, and C1 was equal to -1/12. And from there, we can actually just plug those values in. We get y is equal to -12 times 2, 1, -1, plus 23/3 times our second k vector, which was 1, -1, 1, e to the 2t. And last but not least, we had -3/4 times that 2, 3, 1, e to the 4t. And that would be my particular solution to the differential equation, system of differential equations. So for the work I had here, if you wanted to just take a look, see if this makes sense for you. Hopefully I can get this clear enough. And you can just pause it whenever you need to. Work on the eigenvalues. Lambda equals 2 at the bottom there. And actually lambda equals 4 at the bottom there. Continued on to the next page. And comes down to that. So thank you very much, and good luck on the exam.